Review, Metcel.
Good afternoon, everybody. My name is Balaji Jayakumar. I'm the Operations Manager of Metcel. I'm proud to present Metcel Advanced Honeycomb Manufacturers. I'd like to introduce the management team to you today. We have Amar, who is the Finance Assistant. We have Advait, who is the Development Engineer. And we have Ranjan, who is the Manufacturing Process Engineer. As many of us are aware, the soaring fuel prices and slowing economic growth are the two most prominent factors that led to the downturn of the airline industry in 2008. What it did was it added pressure to the less profitable carriers to take actions to prevail in the industry. After the terrorist attacks in 2001, several industries have taken very aggressive cost-cutting measures to cut down a lot of costs. They've been able to achieve it to a reasonable amount, but not to the fuel cost. In the North America, about 35% of aircrafts are at least 25 years old. And the new aircrafts that are coming in are at least 30 to 40% more fuel efficient than the older ones. So where does the problem lie? The problem lies in the structural airframe of an aircraft. The weight of the structure, the durability, the manufacturing process using which the parts are made, as well as the life cycle associate itself with the costs that come with it. So by analyzing these, we make it a point that we can reduce the fuel, the replacement, production, as well as the depreciation cost. Let's take a realistic example. Consider a flight that is going from New York to Los Angeles. Let's say it's a Boeing 767. Now, American Airlines predicts that it takes about 5.5 hours to go from New York to LA. In that event, the aircraft consumes approximately 7,400 gallons of fuel. An average lifetime of an aircraft is 20 years. So over the 20 years, the aircraft ends up consuming over 20 million gallons of fuel. Let's say we can make the aircraft lighter by 1,000 pounds. In that case, we are saving about 18,000 gallons of fuel per year. Now, how do we convert this into cost? With the kind of fuel price that we are estimating today, we can save about 1 million over the aircraft lifetime if the aircraft is going to fly for 750 hours every year. How can we achieve the reduction in weight? I'm very happy to present our product called Metcel. Now, Metcel comes out of a cellular structure family, namely the honeycomb. We have a unique microstructure that is manufactured using a patentable process. Now, these materials have properties such as lightweight, high strength, lightweight, and have greater performance characteristics. The kind of potential that the product has makes it applicable in a wide variety of applications, ranging from aerospace, ballistics, civil, construction, and packaging industries. But the high volume and the high potential of the aerospace market makes us believe that aerospace is the primary sector for us. Let's look at where honeycombs can be used in an aircraft. To give a brief anatomy of an aircraft, honeycombs can be used in both the interiors and the exteriors of an aircraft. If you look at the interiors, honeycombs can be used in floor panels, the passenger floor panels, also in the cargo floor panels, the walls, the seats, and the exterior, it can be used in wings, flaps, the horizontal stabilizers, the very vertical stabilizers, and it can also be used in critical points such as the wing-to-body fairings, which connects the fuselage and the wing, as well as landing gear doors. Where does Metcel place itself in the competition? The high stiffness and stability characteristics that adds to the performance of Metcel places itself comfortably above the other products. Now, we have a good performance to price ratio, saying that the strength that we offer to the cost that we save is greater than that of what's already in the competition. The aerospace market segment in the US can be broadly classified into two broad categories. One is the civil aviation, the other is the military aviation. Now, civil aviation consists of the commercial aircrafts that carry passengers across the world, and the regional jets that carry passengers inside the US, as well as the business jets that carry the businessmen.
Try moving over, see if that'll make the mic stop. Thank you.
If you look at the total sales in this industry, in 2009, it was about $140 billion, and it's expected to go to about $155 billion over the next decade. Metcel also sees a market segment in the aerospace industry as a potential market, which is the maintenance. There is about $9 billion of cost that is incurred in maintenance of an aircraft. And that amount is expected to increase to about $12 billion over the next decade. Now, maintenance involves the line A checks on the aircraft, that involves the overhauling of aircraft, the parts that are replaced from an aircraft, the periodic checks that we do on a structural airframe for it to live long. What is the target market potential of an honeycomb in an aircraft? The database from IBIS suggests that an average of 4,000 aircrafts are produced each year. A US patent tells us that approximately 280 square meters of honeycomb is required for each aircraft. Using these two values, we come up with over 1 million square meters of honeycomb that are used in aircraft. With an average price of $320 US, we can say that the target market potential is in the order of $360 million. Composite materials are lightweight, high-strength materials that are not just cost-effective but also eco-friendly. If we look back 30 years, there were approximately about 5% of composites used in a commercial airliner. Let's look at a modern Boeing 787 airliner. About 50% of composites are used in a structural airframe. Let's do an even closer comparison. Let's look at an older aircraft. You can see that about 3/4 of an aircraft is built on aluminum. However, in the most modern aircraft, we can see that 50% of it is composites. So we can see that composites are very much replacing a conventional metal such as aluminum. Another important point to be noted here is that titanium alloys are used as much as 5% in the older aircraft, which has increased to 15% in the newer aircraft. Titanium is a very light alloy. It has excellent performance characteristics, but it's comparatively expensive. But the airline industry is ready to pay that much for a high performance metal like that. In order to enter such a big market, Metcel understands that we have to have a market access plan. In the preliminary requirements section, the first step that we'd like to take is to obtain the accreditation of the Federal Aviation Administration. Now, this will give us the first path for the material to enter the aerospace market. Now, this also involves governing regulatory bodies such as AS 9001, the International Standard Organization, and the Performance Review Institute that is governed by the National Aerospace and Defense Accreditation Program, which are going to give us the license to enter the aerospace materials market. Now, the market entry plan for us is divided into 3 steps. In the first phase, we'd like to target the regional aircraft manufacturers. In the second phase, we'd like to go to the original equipment manufacturers. The original equipment manufacturers are those who make aircraft parts and sell it to the integrated part assemblers. The assemblers put the propulsion unit and the structural unit together to build the aircraft. Now, in order to achieve this, we have devised a marketing plan. We understand that the need for new high-performance and innovative materials rises from the tier 1 of the supply chain. So the need comes from the part assemblers who need the parts to build the aircraft. When such a need arises for them, they look back at the original equipment manufacturers for working on the aircraft parts. So once they look at them, they look down at the suppliers who provide materials for them. Now, where does new materials get introduced? They get introduced in conferences, scientific journals, trade shows, and through personal selling. So Metcel's marketing strategy was around the same lines. Now, we'd like to create product awareness through trade shows, scientific journals, and magazines. And we'd also like to do extensive site visits and do beta testing. And once we do product sampling, and if once the customers are satisfied with the performance of our material, then they make a purchase decision. The timeline between the need recognition and the decision of purchase takes about 6 months to an 18-month period. We'd also like to improve the marketing strategy by building bottom-up relationships from the supplier point to the integrated part assembler point through the original equipment manufacturer. The operations of Metcel is broadly classified in two ends. One is the front end, the other is the back end. In the back end, the product is made. In the manufacturing section, we are making our own raw materials in-house, and we are making honeycombs, assembling all the different parts together, and that involves a vertical integration method that we have got, where we make our own raw materials and make our own honeycombs and sell it to customers. In the front end, the customer service works with acquiring sales orders, also distribution and logistics. Aerospace market, being such a big market, has a very high operating leverage. For a company like Metcel to withstand in that big market, we understand that we have to have a very high margin and a very high volume business. The potential of the first product from Metcel, Metacore, has a very high potential to be applied in other variety of applications that involves ballistics, construction and civil applications, as well as to identify other segments of the market to be applied in. Now that will make Metacore sustain in this market. Metcel has expertise and experience in the board of advisors who are knowledgeable in the field of ballistics, advanced materials and finance. The current management team, led by Dr. Jay Hannon, will take all responsibilities to obtain all accreditations and licenses to get Metacore enter the aerospace materials market. Now, the top tier of the management team will be filled upon raising the capital. It is very interesting to look back at the history of where the product was built. Once the product was invented, the initial prototypes of the product were made and were tested mechanically to see what potential it has. Once it was done, the preliminary design was validated using mathematical models to prove that it worked with the theory. And then, once the potential was identified, an initial disclosure was submitted to the Office of Intellectual Property in Oklahoma State University. And currently, we are working on optimizing the product to the requirements of the customer as well as streamlining our production techniques. Now, this project also got identified by the TBAG funding agency in OSU, and we got some funding to work on this as well. And in the future, over the next 2 years, we plan to get past all the quality regulatory toll gates in which we will acquire licenses as well as accreditations from all the FAA regulated bodies, and as well expand the depth and width of the product offering. Metcel projects a sale of $937,000 that is starting in year 3, and is expected to grow to about $60 million in year 10. The gross profit margin for year 3 is estimated to be at 50%, and is expected to go to 65% in year 10. Now, this increase in gross profit margin is justified based on economics of scale and the experience that Metcel gains over the next years. We are also planning to achieve a break-even in year 4 as well as show positive cash flows in year 4. Now, what do we need to achieve all this? Metcel seeks an initial investment of $3 million in 2 phases. $2 million in the first phase and $1 million in the second phase. We'll be using funds for developing the product to establish operations as well as acquire licenses and accreditations for the material to enter the market. Metcel also foresees an exit strategy. The kind of potential that Metcel has and what the first product Metacore can lead to will make it a very good candidate to be acquired by other existing market leaders who are interested in honeycomb business. And we would also license a product as well as the innovative technology that we have to other existing leaders who might be interested. The value of the company, the value of Metcel, at the end of year 10 is estimated to be in the order of $265 million, And the investment, the return on the investment is estimated to be in the order of 79 million, which is 26 times that of the initial investment that we seek. Well, we are Metcel, and we are here to redefine the world of composites. With that, I'd like to open the floor for questions.
Again, we'd like to thank you for your presentation. It's apologize the judges have had the financial summary of the business plan for a short period of time, and certainly a very involved topic. Like a little better explanation of how you derive the ownership split. I was looking at that. I got confused with another one, which came up with 30% ownership in return for the financial contribution of the investment. And how was that derived?
We went to the net profit at the year end of the year 10, and we multiplied that by PE ratio of 12. We had the multiple of PE ratio in the industry at 16, and we took the conservative number as 12. And with that, company's profit was taken as down for the present value by the discount rate of 40%, which is generally sought by the venture capitalists. With that number, we came up present value as 10 million, and whoever invests in our company for 3 million, we took it as around 30%.
I didn't see a set of milestones, and maybe I'm missing, but what important milestones in your company would the investor expect to be achieved, and what would be the penalty, or what would be the change if the milestones weren't achieved?
I think the most important milestone for us is to strike a contract and get our sales going. And in the case of that not happening in the aerospace market, the potential of the product will let us explore its options in the ballistics market. This has a lot of applications in the military sector where this can be used as body armors. So we would certainly look at the other markets that we can explore.
You look at the graph that you presented on the percentage of composites in older aircraft versus the new aircraft. I don't know exactly what the year runs at, but are you concerned, or should the investor be concerned that there's a time cycle to your company's obsolescence as older aircraft are retired, that they would be eventually cycled out, and 10 or 15 years down the road your company would not be relevant because of all the older aircraft would have been retired and have been replaced with higher composite material aircraft, that there wasn't significant savings?
We think that the maintenance part is 9 billion as was projected there, and the latest aircraft that are coming are looking towards lightweight materials of lightweight, and through our extensive R&D we'll be able to keep up with the competition.
Last thing I think, and I'll pass it. I did not see in there, is there currently work on process patent, or is this unpatentable within industry, or unpatentable with regard to material? Is there any protection or barrier to entry associated with your technology?
Yes. We have submitted a initial disclosure with Oklahoma State University, the Office of Intellectual Property in Oklahoma State University. But we're waiting to...
Is it for a process patent or a material patent?
For both. We're using a unique manufacturing approach, and our material is unique with a unique similar structure as well. So we are trying to patent not just the product as well as the technology.
Maybe to follow up on that last question, what's your confidence that you'll be able to prevail with these patents when your peers out there challenge them, and if they challenge them and overthrow your patents, do you think you can still succeed?
I think if you can put up the slide, if you can refer to the graph that we have projected before, we are currently 6 times, or let's be conservative, let's say twice as better as the competition. And if you look at the time period that we're projecting, at least for the next 4 years, we're going to be the best in that category of the product. And like we have already mentioned, we're trying to extend our capabilities beyond this. We're trying to investigate newer materials that will still make the product better than what it is right now, and it will keep us going into competition. And I'm pretty confident that this is going to survive.
Because we didn't get a lot of time to read this, was your patent or design work with any composite material, or is it P2B titanium, aluminum, or does it matter what the material is that you use?
The material that we're considering right now is proprietary, so we're not trying to disclose too many details about it, but it is one of its kind. It's the first time as anybody has tried to do this. Over the past few years, we have been involved in trying to see how we can bring this to the composites world, the current material that we're using, and we have been successful. So it's my guess that we are the first ones to do it. We're going to try to involve other similar materials in the same category to be incorporated in our product, and then over the years, I think we will have a good chance.
I have a basic question on the technology. These honeycombs, carbon-carbon composites have been there for 30 plus years. All these commercial aircraft companies have extensive, Boeing, Lockheed has extensive labs in which they have been working for many years. Wright-Patterson Air Force Base is working on the military side of it. Why is your product better than them compared to the R&D dollars they could spend? Here you want a small amount to be spent. Tell us about the technological advantage you are having so that you can compete with these guys.
Like I already mentioned, the product that we have is based on a material that is unique. Like people over the past few years have tried to incorporate carbon nanotubes, something similar to fabric-based systems like Kevlar. Nomix is a company that produces this kind of honeycombs. But the advantage that we have is all these companies are using a top-down process for making the honeycombs. If you might have been aware, the procedure is based on an adhesive or abrasive kind of a technology. What we have here is a unique approach wherein we are going from bottom up, which gives us an advantage of even customizing the product to the exact needs. It also enables us to change the morphology as per the requirement. And I think why people have not been able to do this so far has been the limitations that the base material offers when it comes to processing. And the technology that we have here has been devised to counter that measure, and we have been successful. And I think this is something that is going to be really groundbreaking. If we are able to take this to another few materials on the same lines, then we would be the biggest company who are making these kind of products, not only in Oklahoma, but also in the United States.
Have you considered, instead of going through the process of building your own company and doing all that, just take the idea, sell it at this level itself to the bigger companies?
I think at this level, there are a few processes that we would like to streamline, like the manufacturing processes and fabricating. That we are pretty confident that the process that we have come up with is a scalable process, and honeycombs can be manufactured on a really large scale, and customizable honeycombs can be manufactured. So once we come up with the right process, and once we come up with the right mix for the base material, then maybe what you suggest, we might be like this, thinking of going ahead with it, but not for the next 8 years, 10 years.
I want to make sure I'm not parsing your words too carefully. And your business plan says that Metcel owns the rights to produce Metacore. It's not uncommon for one company to have the right to produce, but not necessarily own the intellectual property. So, are you proposing a structure here where the intellectual property will actually be owned by Metcel, or is Metcel simply a duly licensed manufacturer of the intellectual property that is owned by some other entity or people?
I think we're trying to explain the layer part of what we're trying to do. We have submitted an initial disclosure to the OSU Office of Intellectual Property, and we have initiated talks with them regarding manufacturing this once we streamline the other aspects of the product. And this will be based on a negotiation process with the IP Office of the OSU.
Okay, so this would fall under the OSU program where it would be licensed from the OSU Technology Transfer Office. Okay.
Will it be an exclusive license?
Yes.
Yeah, typically it'll be a royalty agreement incorporated in the city. I just want to make sure I understand who owns the intellectual property as opposed to who owns the licensing. When I first read this, or the industry you're playing in, I mean, it's all very exciting. I commend you guys. It's just great job all around. But $3 million of capital sounds just extremely optimistic. Have you run, or what if it takes 10? What if it takes 50 to get you where you need to be? Have you talk to me about tell us about your contingency plans. What if you run out of $3 million? $3 million is not enough. What then?
I believe the revenue generation, based on our cash promoted, we had the 3 million at the beginning, and we were trying to support ourselves by the revenue generation, and we are assuming that we'll get starting making money after the year 3. And I understand your question, like if we cannot make the revenue generating after the year 3, then we might have to seek for the additional capital infusion for our company.
In your chosen industry, in the aviation industry, it seems to me that the use of kind of the development stage where you're using the build fly group at Oklahoma State, and you're using, if I'm not incorrect, Oklahoma aircraft manufacturing, it seems like, I may be incorrect because I may not be as familiar with these groups, but it seems like a very indirect, uncontrollable path to proving the technology. Was there an alternative path of testing, Southwest Research Institute, or more conventional testing methodology considered and rejected in favor of this kind of open-ended?
To start from the lab scale, we thought the logical standpoint would be to talk to the design build flight team in Oklahoma State University. A team from Oklahoma State University participates in the design build flight competition where they make aircrafts and do experimental testing. The other alternative, or I might even call it the plan A, is we have been initiating talks with Nordam, which is a parts manufacturing company in Tulsa, as well as Spirit Aero Systems, second a parts manufacturing company in Tulsa. And we have introduced a product a little bit, but haven't spoken to them about the most part of it. But they have shown an interest in the potential that our product might have for them.
So you say
I tested it recently over the past 1 year, and this is a successful plate that has been able to stop at least 5 shots with a 7.62 mm, which kind of gives us an idea of how much energy absorption or the strength the material can give. Since it's on the similar lines as these products are, we can probably go ahead and put it in the structures like these are, and then try to experimentally test the strength once again, because this is a totally different application as compared to these, right? And that is what the plan is for the next few years, to actually put them in structures that we designed to put them in and see the potential for it.
Because I'm not too technically confident, is your real competitive edge the composite material you're using versus the cellular design?
I might want to explain this a little bit. This is a typical aluminum honeycomb. Observe closely, these are hexagonal cells. Our microstructure does not have a hexagonal cell structure. We have a unique microstructure That has not been made before from the research that we have made. And this base material is aluminum, and ours is not aluminum. Ours is an advanced base alloy that has not been extensively tested in mechanical applications. So that would give us an edge over.
So it's a bit of a competition.
So it's the shape of the cell
Yes.
and the materials used to form. Yeah. Got it.
Are you going to have any problems getting the material? It's not one of these rare metals that China seems to be monopolizing.
We have identified manufacturers in the US, very scarce, very limited number of manufacturers who does not use these materials for mechanical applications. They use them for magnetic applications. They have not identified the mechanical potential behind the material that we seek for. That gives us an edge.
I'm not sure that makes sense. You will have access to another material?
Yes, sir.
We even plan to like extend our capabilities to make our own CO1 because we are familiar with the manufacturing of CO2s.
So your price point is competitive with?
Yes.
What's the lifetime of the, what's the average lifetime?
Well,
How long will the Medicore, what's the, I don't know how to.
durability of the
Thank you. Duh.
Well, we're glad that answered.
It's more to do with the application.
Okay.
Where it is. And in the aerospace segment, we believe it will go, it will be more durable than the existing honeycombs, but we still have not conducted durability tests.
we would like to counter check this and be sure of that.
Have you seen previous attempts to revolutionize this design?
Yes.
There are other microstructures that have come in, circular microstructures, corrugated microstructures, and we have mechanically tested the other microstructures, and we have mechanically tested our microstructure, and we're trying to build an analytical model that will tell us what impact a microstructure can make on a mechanical property that material can provide.
How convinced are you that your microstructure is competitive with these other evolving, potentially competitive microstructures? Have you done enough testing to?
Yeah, he was a part of both of our research projects here. We are both master's students from OSU. We graduated last semester. We presented our theses. We worked under Dr. Jay Hannon, who is here right now. And in this research work, we have compared the mechanical properties of our product with similar ones. What we call this is competitive aerial density. It's kind of like a term to see how much heavy the stuff is. And the strength it offers is kind of correlated with its weight because all these applications that we're talking about are weight sensitive. So we have done some primary testing and we have found that our product was better. And the numbers that we have put up here are based on those testings.
The airline market, whatever, if that market were to just dry up for whatever reason, Hexcel comes out with some new big thing or whatever, you just can't get into it. What other markets exist for the technology?
Yeah, ballistics is the primary market. We have already proven the technology. Other markets would be marine industry, wherein they're using honeycombs to make these structural frames. Other things involve all the packaging industry that have used honeycombs for protecting the cargo. Apart from that, we have also located a couple of construction or furniture-based industries who involve honeycombs to make lightweight structures.
And we think it can be further extended to the high-end automobile industry where they're making the wheels of automobiles to make honeycombs.
Yeah, because they have a lot of potential for energy absorption. So anything that pertains to this can be potential market.
The other companies that have gone away from the hexagon that do this CAD, everybody probably has an acronym, but are they in business? Are they succeeding?
Yes, they are succeeding because their applications are kind of being limited to a certain extent. Because if you notice, if you try to curve that thing, it's going to come up on the other side. Did you see that? And that is the reason why this microstructure doesn't work on curved surfaces. But what we have works really well on curved surfaces. And that's the reason why people have even investigated other microstructures that are good on curved surfaces. And the reason why they have been successful so far is the market range is so big that even in applications where you just make floor panels like the one we have here, it's sustainable.
That's time. Thank you, team. Metcel.